Alright, so this is section 8.2 called linear functions, and I've actually gone into your software online and pulled up the book, because you have an e-text when it comes with your software. So here we're recognizing representations of linear functions. So just to put this in context, suppose that the air conditioner is turned on when the temperature inside a house is 80 degrees Fahrenheit. Then the result of the temperatures are listed. So here is the table for the air conditioner. So here's the amount of time that's lapsed, and then here is the temperature. So at 0 time, the actual temperature is 80 degrees. And so as we increase by an hour each time, that's what's happening here. That's our x value. It's increasing by 1, increasing by 2, increasing by 3. You can see that the temperature is also decreasing by 2 degrees. So it's decreasing. So 80 minus 78 is 2 degrees, 78 minus 76, 2 degrees, and it goes throughout the whole thing. So this is a constant setup that we're doing here. So let's go ahead and put this into more perspective. Let's look at the graph. Okay, so let's first of all create this table. So I'm going to create this table that we just saw. And so here's x and then f of x. Okay, after 0 time, right, hours, then it was automatically 80 degrees. And then we have 1, which is 78 degrees. After 2 hours, it's 76 degrees. After 3 hours, it's down to 74. So you can see the difference between these two numbers is 2. Is always 2. And same thing here. This is 1, 1, 1. And so in the table, we're seeing this constant number occurring. And so basically, this is referring to what we call a constant rate of change. And then later on, we're actually going to call it slope. It's another way of saying slope. And we always use the letter M for slope. So that's what this symbol letter will be, meaning constant rate of change or slope. Okay? And we can also see this not just in a numerical representation, but also in a graphical representation. Let's say we made a graph of this particular set of points. Okay, so I'm going to put these little hash marks here because I really have really high points, and I don't really have much data that starts at 0 for y. So I'm going to go over and say that this starts really at about 70. Okay, so this is 70, 74, 76, and 78, and then 80. That way I don't have to put it all the way starting from 0 up to 70. And then of course I'll go over to, let's say, 5. So 1, 2, 3, 4, 5. Okay? And so now when I put the points in, I can see this set up. I have a point 1 here, over 1 up 78, and then over 2 up 76, over 3 up 74. And so as you look at it, it's actually going down 2 and going over to the right 1. It's going down 2 over to the right 1. It's going down 2 and over to the right 1. Okay? So that's what's happening in the table. And so again, we're seeing this constant same number each time. Down 2, down 2, down 2, to the right 1, to the right 1, to the right 1. And so again, that's relating back to the constant rate of change. And so this is in a graphical representation. Okay? And then I could say it in a verbal way. So a verbal way of saying it, like I've been talking about, is, hey, let's just multiply x by 2 degrees, by, let's say, minus 2 degrees, sorry, and then add 80 degrees Fahrenheit. Okay? And so here's my verbal representation of this particular problem that we're doing. And then if I want, I can do symbolic. The symbolic would be the actual equation. So that would be my symbolic representation. So symbolic would be something like f of x is equal to negative 2 degrees multiplied by the x and then add the 80 degrees. And so this is my symbolic. And so this refers to the linear function. And so the way we write a linear function, okay, our linear function has to be f of x equal to m times x plus b, where m will be my constant rate of change, or what I said before, slope, and b is going to be my start point. Okay, or I could call it the y-intercept. So the y-intercept is another way of saying it. But again, the b here will be constant, it won't change, and so will my slope, it won't change either, because we see it all the time. It never changed. Went down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. So that stays constant. Okay? And so this is basically the setup of all the different forms of a linear function, showing it numerically, graphically, verbally, and symbolically, and then finally we'll identify the linear function in the next video.